So here's the good news. Even though you're going to learn a new shape of a graph, the process for how you do these is not any different than sine and cosine. How you go through it and what the process is not any different. So you really kind of already know how to do this, right? Here's the one thing that's going to change. These all say cosecant. Cosecant is the reciprocal of which function? Which one? Sine. If you flip sine, is sine the x part or the y part of those points? Sine is y. So for cosecant, you are going to flip the y value. You want to write yourself in it. You've learned it before. We're just reviewing it. You're going to go around your circle and flip all of the y values. Now I've got it on the board behind me and you wrote it on your paper. Hopefully we're going to look at that. At 0 pi, what is your y value? 0. You cannot flip 0. Do you remember what we put for that? Undefined. That means the graph will have what? An asymptote. Good. All right, pi over 2. That's at the tippy top of the circle. What's your y value? Up at the top. 1. If you flip 1, it is 1. 1 over 1 is 1. How about pi? 0. If you flip 0, undefined. 3 pi over 2. Now you're at the bottom of the circle. What's your y value? -1. If you flip -1, it's -1. 1 over 1 is 1. It's just negative. And then 2 pi puts you back where you started, which is undefined. Now we're going to go around the circle backwards. Where are you on the circle if you're at -pi over 2? I'm looking for a word like up, down, left, or right. Down, that's at the bottom. All right. What's your y value? And if you flip that, -1. -pi, now you're on the left side. So what? Undefined. Are you seeing how every other one is undefined? It's very process driven. Once you get it started, then usually you can finish it up. It's pattern, they're cyclic. All right, -3 pi over 2. If you go backwards 3 pi over 2, now you're where? Top, which is 1. If you flip 1 at 1, and then this puts you back where you started, undefined. So we're going to take these points and asymptotes and put them on the grid. So at 0 pi, and you're going to have to look at your paper because I want to keep moving this up and down, make you seasick, all right? At 0 pi, you have undefined. That's going to be an asymptote. And then at pi over 2, it was 1. And then you have another asymptote. And then it's going to be -1. And then, bless you, and then another asymptote. Bless you. And then +1. Could you keep that pattern going for the rest of it? And I'm sorry, I know my hand's in the way. It's because I'm right-handed. I'm trying to draw it as quick as I can, and then I'll get out of the way. But do you see what I did there? You got a point and then an asymptote, and then a point and then an asymptote. Now, the way that this looks when you draw it is U shapes. I try not to call them parabolas. If you do, I'll let it go, but they're technically not because it's not quadratic. This is trigonometric. It's a trig function, but they do end up being U shapes. I tend to just call them smiley faces and frowny faces, but they're going to look like this. You remember how for sine and cosine, I said don't put arrows on the ends? You can put arrows on the ends of these ones, and why is that? Like, why is it okay to put an arrow? Yeah, it's going to keep going that same direction forever and ever. So you get an infinite number of these smiley faces and frowny faces. Now, don't write this on your paper, but what I want you to see, can you watch me draw this in? Because I'm going to end up erasing it. What do I get if I draw in this? Do you see what I'm doing there? That's a regular sine graph. Sine and cosecant are reciprocals. We took the sine wave and turned it literally inside out. Isn't that cool? It's kind of cool. It's cool, guys. You took the wave and turned it inside out. Now it's going the other way. Neat. All right, now down here for the characteristics, we're going to list out the exact same things we did on the other ones. My idea with these is you're going to have a little exploration for all of them, and you can put them right next to each other and compare and contrast. So we're going to start with domain and range. So this graph is going to go left and right forever. You have an infinite number of these U shapes, but you have to leave out where the asymptotes are. The problem with that is there's an infinite number of asymptotes. So here's how we write it. It's all x not equal to. So what we're saying is it's everything except for where the asymptotes are. And here's how you write it, because there's an infinite number of them. You can't list them out forever. There's an infinite number of them. You take the first one, and that's either the first positive asymptote or 0 if it's 0. Do you see how the first asymptote is on 0? Okay, so the first one is 0 pi, and then you're going to write plus how often they happen. So look we have one at 0. Where's the next one? Pi, and then 2 pi and 3 pi. So they're happening every how often? Every pi, you get another one. So we write pi n. Every pi, you get another asymptote. So it's everything except for where those asymptotes are. The range is a little bit more intuitive. You're going to sweep downwards to upwards. What do you get for that? If you sweep downwards to upwards? Good. Negative infinity to -1. Bracket or parenthesis on the -1? Bracket. Union, good, because you're missing this part in here. 1 to infinity, good. And again, that's the exact opposite of what we had for the range for the sine graph. Sine was just -1 to 1. You were stuck in between those. Now you're on the other side of it. Is this continuous or discontinuous? Discontinuous. Are those called removable or non-removable? You're like, why is she torturing us? Removable or non-removable discontinuities? They're non-removable. Remember, removable is a whole, like you just took a point out. All right, even function or odd function? It's going to come up later which ones are even and which ones are odd. It is important. Do you see how this part up here reflected across the origin to this part down here? So this one is odd. Sine was also odd. Interesting how those go together. If sine is odd, cosecant is also odd. All right, and then I wanted to write out the period. That's how long it takes to finish one cycle. That would be one smiley face and one frowny face. So look, I'll cover up everything except for one cycle. Do you see how you have one facing up and one facing down? How much distance is that in there? Oh my gosh, it's 2 pi. Isn't that crazy? Why is 2 pi make sense? The circle. Once around the circle. And then the last thing I really want to stress here, maybe put some stars next to this. The amplitude. Oh, what's that? Oh, I did, because I was talking at the same time. Can't spell and talk at the same time. I'm also just a poor speller. The amplitude is none. There isn't one. An amplitude, by definition, only applies to a wave. This is not a wave, so there just isn't one. So please try to remember to just put none, because that's an easy answer, and I don't want you to miss it. But people put a number there, and then I have to mark it off. Amplitude is only for a wave. This is not a wave, so it's not. What I want to do, I'm going to stop talking at you. I want you to try this side. The only difference between what we just did and this one is, since these say secant, how do you get those values from the circle? Yep, you're going to flip your x values. And I have it on the board up there. You can just look back at that, so give it a try. Did you guys get something that looks like that? Remarkably like what you had on the other side? But it starts at a different spot. That's the only difference. Same with sine and cosine. Do you guys see how if I drew the wave in between, that would be the graph of cosine? It's like you just took the cosine wave and turned it inside out. Okay, sweet. So we're going to state the same things for this one. Start with domain and range. I'll pull us all back together. If your graph was good, that's awesome. So the way we write domain, it's all x except for where the asymptotes are. So you take the first one and it's the first positive one or 0. Now this one's not 0. So where is the first positive asymptote? Pi over 2 plus however often they're happening. So how often do you get another asymptote? There's one at pi over 2, 3 pi over 2, 5 pi over 2, every pi. So it's pi n. The n just stands for any integers. So it's like taking care of the fact that there's an infinite number of them is what you're doing. All right, how about range? Yeah, that didn't change, right? That's still same as it was for sine. All right, this is discontinuous. Even or odd. So here's your y-axis. Do you see how it reflects over the y-axis? Like what's over here is going to reflect over to here. Do you see that? Okay, so that means it's even. Cosine was even, so secant is also even. Do you see how they go together? The ones that are reciprocals of each other are going to go together. So sine and cosecant were odd, cosine and secant are even. Again, it's going to come up later, so I'm bringing it up now. All right, and then what is the period of the function? 2 pi, again, it's once around the circle. And the amplitude is none. There just isn't one because it's not a wave. That's just, that definition goes with a wave and it's not a wave, so there's isn't.